Hey, well, welcome to what I would call day number 2 of Physics 0102, and hopefully the first day, which involved those first 2 lectures, the first one being the introduction lecture and the second one being chapter 1. Hopefully you saw all those and you've worked on the homework and learned to scan them and getting ready to turn them in. Like I said, homework's not really due till June 1. This will give us a learning time. In fact, hopefully it's going well for you. We've learned a few things. We still haven't got our lapel mic that we ordered. Got somebody right now over at the post office, and so hopefully that will improve the sound quality. But I think the sound's coming out pretty good. I'll just try to remember to talk really loud, especially when I get over to the board here, and I think this is working well here. But we've learned a lot, still have a lot to learn, and I would assume you are too, learning this new strategy. Me teaching remotely and you learning remotely. Well, with that said, let's move on into chapter 2. And so this is day 2, and so the goal here is to first lecture on chapter 2. We'll do that first, and then the second lecture for today will be chapter 3. And so let me begin with chapter 2. I'll grab my notes here and move to the far side of the board here. And I would describe chapter 2, if I could use the word describe again, as describing motion. In other words, we're not going to try to explain why an object, when we drop it, falls. And in fact, the lab you're going to do, your first lab, is exactly that. When you're done with this lecture, you should look at the first lab lecture. I shouldn't call it a lecture, but the first lab you're gonna work on. And you'll see that we drop this object that we affectionately call Bob. Today I just got some baseballs over here, and we'll drop those. So we're not going to try to explain why they fall yet. That's coming up in the next lecture, in the next chapter. So this is just describing it. We're just saying if it does fall, how does it fall? How fast? How far? How long? And that's why we call this chapter the describing motion. And so we start our physics with motion. You might remember me going through the syllabus, and I said, okay, we're going to do motion first, and that's how we kind of begin to describe it. And so, like I said, let's describe our motion. Now, let me kind of pick up today where we left off yesterday. And that is if I make a little chart. And on one side of the chart here, I put the quantity with then the symbol for that quantity. And then over here, I put the units that are used to measure that quantity. I have this little table. And I was trying to set the stage in the first lecture that we're just going to keep asking the next question. So if you remember at the last lecture, we had 5 objects over here. We had distance, we had area, we had volume, we had time, and we had mass. And so each of those were their own concept. And let's keep going, because today's goal is to teach you about velocity and acceleration. That is what chapter 2 is. And so we can describe our motion by saying what is its distance or its position, which we already talked about, what is its speed, and what is its acceleration. And so those are the 3 things: its position, its velocity, and its acceleration. What do those things mean? And so that's the highlight of where we're going here. In fact, maybe to give you a rough idea, here's the stage, if you will. If I start on this side of the room and I move to this side of the room, as we talked about, if I did the whole room, that's 10 meters. And then yesterday we said, Well, we could also say how much time did it take. And so yesterday we were using a number of 5 seconds. We said, okay, so it'll take 5 seconds to move across the room. So the next natural question is this question then what you might refer to as, in a math class, the rate. At what rate are you doing? In other words, how much do you move every second? And so the rate at which you move, not how far, not how long total did it take, but the rate is the new concept. Rate is the new question. It's the new quantity. And so over here, I would say, let's talk about the rates at which something moves across the room. Now, we're going to then call this the speed. But remember those 4 steps we talked about. Would we ask a new question, like, in this case, what's the rate? That should lead to this new idea, this new quantity, which should lead to a new formula, which should lead to the units and then the interpretation of those units. And so let's do that with speed here. And so if I come over here and I say, okay, let's talk about speed of something, what would the formula be? If I'm talking about the rate of something, then those words that I just described would be distance per time. It is a rate. It is how much distance did you travel in that period of time. Now, if we put them in symbols, yesterday we said let's use D for distance, okay, and let's use T for time. What will be new here, I'm sorry, I shouldn't have put equals there, I should put a slash. We need a symbol for this speed. Now, this will be more obvious as we move along, but let's just use the symbol V, which is more standing for velocity. And so more on that in just a second. But if you'll go ahead and let me use the lowercase v for speed and also for velocity. So I'm going to put here velocity. And there is a slight subtlety between speed and velocity. And so I'll get to that. But in terms of a calculation, there's not necessary to point out the difference. So I'm going to use, just like your book does, I'll use the V for the speed or the velocity and not distinguish between the two for a moment. But this would be that formula. And so, again, here is the concept. The concept is as I move across the room, and again, my whole distance is 10 meters. The time is 5 seconds. But something that is related to those two, but it's not quite the same, is this question: what's the rate? In other words, how much do I move in 1 second? And that is what we mean by the rate. And that is something a little different. It's not the total distance. It's not the total time, but it is the rate. So let me explain here. Let me keep going on here. Because I want you to understand the quantity. That's step one, a new question. Step two is the formula. Okay, so it would be distance divided by time. And so if I put in some numbers, and so in this case, if I say I move from one side of the room to the other, I might put in 10 m for 10 meters. And the time it takes is 5 seconds. Now, if I do some math here, I'll start with the easy stuff. The 10 divided by 5 is 2. But let me make this real clear from the first lecture here. This means 10 times m. This means 5 times s. So if I divide, what I'd be left with would be a meter divided by a second. And so just like in your math class, if you had, x divided by y, you would just leave it that way, x divided by y, and that's what I have, meters divided by seconds. And so this is 2 meters, and we like to say it this way, per second. But this answers this other part of the question over here. What would be the units to measure this new idea? And it would be meters per second. I'll just put on the side over here miles per hour, because you're probably familiar with miles per hour as a unit of speed. Now that's the empirical unit, so that's not what we're going to be using here in a science class. But miles per hour, notice it has a distance and then it has a time. And it's a rate. If your car is going 60 miles per hour, you don't mean that you went 60 miles. You don't mean you went for 1 hour. Well, what you mean is at that rate, you would go 60 miles in 1 hour. You may travel less or more than an hour, but if you did travel exactly 1 hour, you would go then 60 miles. And so that's this idea. Now, that brings us to point number 4, is the interpretation. What does this really then mean? And so let me just recap. Do you see those 4 steps? Step 1, thinking about a new idea, asking a new question, coming up with a new physical quantity, something that, again, is not human-made, but human-discovered. And so we discover nature. That's what physics is, discovering the physical world. And so there's this idea of rate, which, of course, step 2 would lead to the equation, whether you write it in words or in symbols. And then, of course, there would be the units to measure this new quantity, which in this case would be meters per second. And then the final step is the interpretation. What does 2 meters per second mean? Well, I'm glad we do this one first, because I think you probably already know. We're still kind of reviewing. We're still not really giving you anything you haven't seen before. But when I see this as 2 meters per second, and so I'll even say it meters per second instead of saying meters divided by second. But 2 meters per second, this is my rate. This means I move 2 meters every second. Watch, if I were over here, 2 meters per second means in 1 second I would have traveled 2 meters. And in the next second, I would go another 2 meters. So that's a total of 4 meters so far. And in the third second, I would go another 2 meters. So now I've gone a total of 6 meters. And then in another second, I'd go another 2 meters. So that's 8 meters after 4 seconds. And then finally, I'd go another 2 meters for a total of 10 meters after 5 seconds. So the interpretation here, this rate is how much per each second. How much distance did I travel each second? So this is saying I'm going 2 meters every second. Okay? Now, there's a couple of fun things in here that hopefully is pretty obvious to you. But in this equation, notice, let me just kind of clear this off here. But my first formula then would be to say, if you take distance and divide it by time, you get this speed. And that's what I just did. I gave you the fact that I went a distance of 10 meters in 5 seconds and came out with 2 meters per second. But as you'll see when you do the homework for this chapter, if you are given any 2 of these, you should be able to find the third. So let's rearrange this equation. In other words, what if I gave you my speed and the time? Could you tell me the distance? I mean, if I told you I was moving across this room at 2 meters per second and I went across for 5 seconds, could you tell me how far I went? And I guess the way to do that is maybe to start with what we already know from the definition, maybe multiply both sides by time. And of course, using our mathematics, time divided by time, we say cancels. Maybe a better way is to say it comes out to be 1. 5 over 5 is 1. So on this side of the equation, we just have distance. This side, we have speed multiplied by time. Let me write it on the other side of the equation. And so if I gave you these two, you can find that one. Just like if I gave you those two, you can find that one. So in this case, I might give you that, hey, your speed is 2 meters per second. The time you're traveling is for 5 seconds. How much distance do you do? Well, again, here's a good example of what we learned yesterday with our units. I'll start with the easy stuff, our numbers. Remember, all of this means multiply and this means divide. So if I put my numbers together, that's the easier part. That's just 2 times 5, that's 10. But watch what happens, and particularly here. Here I have an S for seconds over an S for seconds. And just like time over time is equal to 1, seconds over seconds is equal to 1. So sometimes we just say cancel, because it kind of goes away, but it's actually a 1. And then, of course, then 10 times that 1 is still 10. So that's why we say it just kind of goes away. But it, like I said, it doesn't really go away. It's the number 1. And then we're left with meters. And so again, notice I'm treating my units with the same mathematics that I did for my numbers. And you saw that in yesterday's lecture when I did area and volume. But you'll see it here. By the way, this then is called unit analysis, and it is a nice little trick that you'll see me, especially as we get to harder ones, because notice that I, after working out my math, get the units of meters. And the question that's being asked is, what is distance? I know distance should be measured in meters. So if I do all of this work and it doesn't come out to be meters, that's an indication that I did something wrong. And so we call this unit analysis, because pay close attention to your units, your meters, your seconds, and if they don't come out right at the end, you know for sure you did it wrong. Now, sadly, if the units come out right, that doesn't necessarily mean you did it right, but it's a good indication that you might have done it right. But it is for sure you know you did it wrong if your units come out wrong. Well, let me show you the third one too. That's hopefully fairly obvious to you, but I could ask it the other way. Because remember, any two of these, I can find the third. So the first time I did this, I gave you distance and time and found speed. Now I just did it by giving you velocity and time and asked for distance. The third option here would be to say, okay, well, what if I gave you velocity and distance and asked for time? In other words, what if I did this? What if I said, okay, I'm going to start on this side of the room. I'm going to move across the room. And I'm going to say that the distance is 10 meters. The speed I'm going to move is 2 meters per second. Could you tell me how much time it took? Well, looking at this math, and again, maybe starting back here with the definition. The question is, how much time did it take? So let's see if I can rearrange this equation to get time by itself. And so, as we did in the last step, maybe the first thing to do is to multiply both sides by time. Which brings us back to where we were over here. Okay, I guess we could have started there. But then, to get time by itself, let me divide both sides by velocity, or speed. There's a little difference between them. I haven't mentioned that quite yet. But here, I have velocity canceling with velocity. So again, just like we said back over here, t divided by t is 1, I would say v divided by v is 1. and we'll just say cancel, it goes away. And so you end up with a formula that time equals distance divided by velocity. So there it is. I'm going to give you these two, and you got to find that third. Okay? And so I'll say it again. Note that here is the new idea, speed slash velocity. And it's got three variables. And so if I give you any two, you hopefully can find the third. And so we've got that option. We've got that option. And this is a little harder one, so I did it last, but let's do this one to wrap up this part of it. All right, so the distance is what? 10 meters. The speed is what? 2 meters per second. How does that calculate out to be? Well, 10 divided by 2 is 5. 5 what? Well, let me emphasize, last lecture, what does this really mean? And the units are treated mathematically the same as numbers, the same as symbols. And it might have been a while since you've done fractions. So let me write it this way. Let me write it as a meter over 1 divided by a meter per second. And let me take you back to, I think it's 4th or 5th grade. How do you do these compound fractions? If I had over here 7 divided by 2/3, what would you do? Well, I guess you would start off by making a compound fraction. And if these were numbers, what you do is we call the phrase, we flip and multiply. We never really divide compound fractions. We flip it and multiply. So all we have to do is know how to multiply. In other words, we would do this. We would take 7 over 1, and then we would flip this, which would make 3 over 2. Now we're multiplying, and so multiplying in fractions is easy. You just multiply across the top, so there's 21, and you multiply across the bottom. And so I get 21 over 2. So I'm going to say the same thing here, but I'm going to use it with your units. So this is 5, and I'll have meters over 1 here. And then I'll flip this, seconds over meters. And then I will notice something very useful here. Meters on top would cancel with meters on the bottom. So a meter divided by a meter is 1. And that 1 times the 5 is a 5, and I'm left with a second. And so I've come up with 5 seconds. And I also should do my unit analysis. Remember the question. The question is, how much time did it take? So what unit should I get by the end of my calculation? Well, seconds. So did I get seconds? Yes, I did. And so follow your units through, put them into the equation, have your units follow the same rules of mathematics that your numbers do. I know you've done a lot of mathematics with numbers. Now I'm just trying to emphasize, do that same mathematics with your units. And I know you've done some classes, usually a science class with units. And so you probably have less experience with the units. But unit analysis can be very, very useful. And so you see that now. Because if I had made a mistake with this formula getting to here, then I don't think my units would have come out this way. And I would have caught my mistake. I would have said, oh, wait, whoa. It doesn't work right. And so unit analysis is a very powerful tool. It helps correct any mistake. So if I had come up with any other units other than seconds, that would have been my clue that, hey, I did something wrong back here. Something was wrong in my logic at the beginning. All right, well, this is the first, not quite half, but the first part of this chapter 2. And it's just trying to get you to understand this new quantity and realize that this new quantity called speed is a rate. And it's probably not even new to you. So like I said, it's probably a good one to do now because it's not truly a review. But I want to emphasize then how you work with your unit and emphasize that if you ever have a formula like this In this case, we have 3 variables. Given any of the 2, you can find the third. It doesn't have to be the one that's written. You can rearrange it to get any of them by themselves. And so we start with velocity by itself, but we can rearrange it to get distance by itself, or rearrange it to get time by itself. And you'll see that in the homework. You'll be asked to do that many, many times. They'll give you a problem and a scenario, and you got to realize, hey, this is involving speed and distance and time, and they'll give you 2 of them, and you got to find the third. Okay, so that'll be your challenge then on the homework. Now, let me keep talking here, because there is a little subtlety here. Maybe it'll make more sense if I did this. This is usually my example, but sadly, because of the pandemic, not only are we teaching remotely, but the Dodgers aren't playing. I heard today that they're talking about maybe having the league start, but I like Dodger games, okay? And I know from our area down to Dodger Stadium is about 120 miles. So let me just put on the board here. Let's say this is my home. And then here is Dodger Stadium here near downtown Los Angeles. And so from my house to Dodger Stadium, I'll just put 120 miles, if you'll go ahead and let me do empirical units. And if there's not any traffic around, well, if there's no traffic, I can do a little better. But a combination of a little bit of traffic, mostly in the LA area, and none up here in the Santa Barbara, Carpinteria, Ventura area, it takes me about 2 hours to get there. And so if I were to ask something like, what's my speed? Okay, I guess I'd go speed. Would be 120 miles, and it would take me roughly 2 hours, and I would do the math, and I would go 60 miles per hour. That's my speed, 60 miles per hour. But what if, especially this stretch between Carpinteria and Ventura, if you're familiar with the 101, flying down that part, and a CHP officer pulls me over and says, you were going way too fast. Look, I'm going to give you a ticket. Well, wait a minute, officer. I'm going to Dodger Stadium, or I'm coming back from Dodger Stadium. And so I go 120 miles in 2 hours. That's only 60 miles an hour. Is that too fast? Well, does that get me out of the ticket? And I think you see where I'm going with this. What we've been doing, what we've been talking about, is to take the whole distance and divide it by the whole time. And so this is really what we like to say is your average speed. Or maybe I'll even just put average velocity. Because this is really this whole distance, and I'm dividing it by the whole time. And what I'm trying to get you to see is the number on my speedometer, the number that the CHP officer gets on the radar as I drive way too fast, flying by, is really what is my speed at that instance. And so let me call this the instantaneous speed, or even the instantaneous velocity. You might describe it this as it would be a small distance and the corresponding small amount of time. And in fact, if you know anything about how the speedometer on a car works, it simply has a little magnet on the drive shaft that goes around at the transmission. And what happens is that the magnet goes by a little detector, and as it goes one revolution, it goes by the detector again, and the computer goes, okay, this is that small amount of time it took for the magnet to go. And then when the drive shaft makes this one revolution, it turns the tires just a fraction, but given the size of the tires that are on the car, it's all pre-programmed in the computer, and it knows that distance, and the computer can say, this is your distance, this is your time, and this is what the speed is doing at that instant. And so if somebody were to put on the brakes, or if somebody were to step on the gas and go faster, or put on the brakes and go slower, this would change, and the number right on the speedometer would change. And so what I'm getting at is, we need to be a little more specific here and a little more careful as we go through the rest of this chapter and the rest of the semester, that are you talking about the whole distance over the whole time? So that's an average speed? Or are you talking about what is it doing at that instant? And so instead of writing it as distance divided by time, we might write it as a small distance over a small time. Now, I'll use the delta here. That doesn't really mean a small per se, but the delta is a symbol for change. And I'm going to go ahead, for some of you who are more advanced, and say this would be a small change in time over a small distance moved over a small amount of time, and as the limit as that time gets smaller and smaller, and so a small amount of time really would be just the time for that drive shaft to go around one time, then we would get what we would call the instantaneous. What are you doing at that instant? And so what I'm trying to explain here is, be real careful when I talk about speed or velocity. Am I mentioning and talking about average speed or instantaneous? And I'm trying to get you a feel for that difference. They're the same equation, really. They're the same idea. But the instantaneous, as the name implies, is what is you doing at that moment. And that's what your speedometer is. In fact, technically, I guess you would say your speedometer even is not instantaneous. It is still kind of an average during that one revolution. But that's such a small amount of time, and a car can't really change its speed very much during one revolution of the drive shaft. So we often just say, well, it's as close as we can get, and it's very reasonable. And so that's the instantaneous speed of the car. So the actual number. And that's why, again, the CHP officer would probably still give me a ticket. And like I said, that area, if you've ever driven it, it's just, people just fly. I mean, even myself, I go 80 miles an hour through that area. And then I have to get over to the right lane because people are still saying, get out of my way, you're going way too slow. And so they just go really fast there. And of course, later on, just the opposite is true. You know, I start going over the Hollywood grade there, what's that, Cahuenga Pass there, and you know, getting close to Dodger Stadium, and usually, you know, there's so many cars on the freeway, it's bumper to bumper, and you know, I'm on the brake the whole time. I'm barely even moving, you know, and I look down at my speedometer and I'm going, you know, 10 miles an hour, and we're inching our way and finally getting off on Stadium Way. So yeah, it took me 2 hours to get there. Yeah, my average was 60 miles an hour. But near the stadium, my speed, my instantaneous speed, was way down at 10 miles an hour. And way back here, between Ventura and Santa Barbara, my speed was way up at 80 miles an hour. And so it's an average, and then it's also an instantaneous. You can see here then, there is a difference, but the equation is the same. And for that matter, the units would be the same. You would write this in meters per second and meters per second for that. And so, again, just wanted to make that clear, that be careful with that little subtlety. Well, let me come back to this side of the board, because I'll leave my little chart here. But in addition to all of this, I said that there was a slight subtlety between speed and velocity. And so let me point out that small subtlety. And sometimes that small subtlety is really important. And so what is that difference. And I guess I would describe it this way. Velocity is not quite the same as speed. It's speed and direction. Maybe I'll give you a silly story, but let's say that some tourists came into town from another country. You know, they fly into Santa Barbara Airport and they want to see America. And they start off here in Santa Barbara, and then they're going to travel down to Los Angeles. They want to go to Disneyland, maybe see a Dodger game too, maybe go to the Disney concert hall. Anyways, a lot of reasons. Venice Beach, but they want to get down to L.A. Okay, and they rent a car, and they find you next to the car rental, and they said, "Hey, we just rented a car. You know, where is LA? You know, how far do I get?" And you tell them something like this. Well, hey, get in your car and go ahead and get on the freeway. And if you travel for about 2 hours, you should get to Dodger Stadium. Oh, okay. So they follow your directions. They get in the car, they get on the freeway, they start traveling, they're watching their watch, and we go, well, we're about an hour and a half into our trip, and we want to make sure we don't miss LA, so maybe we should start looking. In about an hour and a half, they look up, and they see a big sign, and it says, "Welcome to San Luis Obispo." And they go, "Oh, okay, well, let's keep going. We're almost there, right? We only got a half hour." All right, well, if you know our area and geography, what went wrong there is San Luis Obispo is to the north. Los Angeles is to the south. And they followed your directions. They got on the freeway. They were traveling in a car speed about 60 miles an hour on average. They're looking for 2 hours. They've done everything right except direction. And so I would ask you, is direction important? Is northbound important?